Hello, I am Christopher Gonzalez, and today's video I will be discussing about transformers. So on this slide it's an introduction to ChatGPT and transformers. ChatGPT, it's an abbreviation for Generative Pre-trained Transformer. It's a large language model powered by transformers. Last video we discussed a bit about transformers, and we're gonna be discussing more in depth about it. So Transformers revolutionized AI by enabling context-aware language understanding. So have you ever wondered how ChatGPT seems to understand what you're asking and responds like a human? It's not just a fancy autocomplete. There's an incredible, powerful AI model behind it. That model is called a transformer, and it has completely changed the world of artificial intelligence. So the picture that I have here that I put on the slide, here I asked it, "Who are you?" And it tells you, "I am ChatGPT, your AI assistant." And you could practically ask them anything. It knows my name. It knows what I'm majoring in. Uh, and it's very interesting using ChatGPT. So today we're going to break it down in a simple, easy to understand way. You'll learn how transformers work, how ChatGPT generates text, and why these models are so good at understanding language. By the end, you'll have a clear idea of why AI tools like ChatGPT, Google Translate, and even AI art generators like Dolly are possible. So let's dive in. So how does ChatGPT predict text? Well, this language model could predict the next word in a sequence. Okay, so on the video on your right hand side on the slide, I typed in "the cat sat on the," and ChatGPT is able to predict the next word, which gives you "mat." ChatGPT generates text one word at a time using probability distributions. Okay, so like I discussed, that in the example, the cat sat on, and the predicted word came out as mat. It could also give you floor or couch. So how does ChatGPT actually generate text? It all comes down to prediction. When you type a sentence, GPT doesn't think like a human. It predicts what word is most likely to come next. Just like how your phone suggests the next word when you're texting. GPT calculates the probability of different words following your input. It picks the most probable one, then repeats the process over and over until it forms a full response. For example, right? Again, I'll bring it up. It's if you type "the cat sat on the," GPT might predict words like mat, floor, or couch because those words commonly follow that phrase. It repeats this prediction process word by word until it generates an entire passage of text. On this slide, I will be discussing about word embeddings and meanings. Words are converted into vectors, numbers, for AI to process. Word embeddings allow AI to capture relationships between words. For example, on the right hand side, I was able to type king minus man plus woman, and it was able to generate queen. This is just amazing. It's crazy how it does this. So now you might be wondering, how does ChatGPT understand words if it's just predicting them, right? So AI doesn't actually see words like we do. It seems it sees numbers. That's what it sees. Every word is turned into a unique set of numbers called word embedding. This helps AI understand relationships between words. Okay. One fascinating thing about word embeddings is that they allow AI to perform math with words. That's pretty amazing. So here's an example. Okay. Here, if you see the video, I was able to type king minus man plus woman equals, and it tells you king represents a male ruler, man represents masculine, and then so on, and it finally came up with queen. That's amazing. So woman, we get queen. It's as if the AI understands that queen is the female equivalent of king. That's pretty cool, right? So on this one, we're going to be discussing about static versus contextual embeddings. Okay, so static embeddings, which consist of word2vec, GloVe, assign fixed meanings to words. Contextual embeddings are transformers that based on sentence meaning. Um, we have also an example that says track in rail track versus track in package changes the meaning, right? Track starts changing the meaning by the type how you phrase them. So here's a great example of static embeddings and contextual embeddings differ. Okay, on the left, the word bank has the same vector in all three sentences. I went to the bank, the river bank was muddy, and Bank of America. Okay, whether it's a financial institution, a river bank, or part of a Bank of America, on the right with contextual embeddings, the meaning of the bank is understood based on the sentence, leading to different vectors. You see? So now we don't have the same vectors how we have them on the left, different vectors. This is why transformers are so powerful. Unlike older models, they can adjust word meanings dynamically based on context. But there's a problem. Words don't always mean the same thing in different sentences. Take the word track, right? We're gonna go based on this example. In the sentence, the train runs on the track. It means a railway path. But in can you track my order? It means to follow or locate something. If AI only used static embeddings, it wouldn't know the difference. This is where contextual embeddings come in. Instead of having a fixed meaning, transformers adjust word meanings based on the surrounding words. That's why GPT can generate accurate responses. It understands word in context, not just as fixed definitions. So here is transformer agriculture and applications. Transformers have two main parts: encoder that understands inputs and decoder that generates outputs. GPT uses only the decoder while BERT uses only the encoder. Sorry. Real world real world application, chatbots, translation, image generation like Dolly that we have here on the right hand side. I have an image of it. It generates images. So now let's look at the brain of the transformer. It's agriculture. A transformer has two key parts: the encoder and the decoder, what we discussed here. The encoder processes input text and understands its meaning. The decoder takes that understanding and generates new text. Different AI models use these parts differently. For example, BERT, which Google uses for search engines, only has an encoder because it's focused on understanding text. GPT, on the other hand, only has a decoder because it's focused on generating text. Okay? Thanks to this structure, transformers power some of the most advanced AI applications today. ChatGPT is used practically everywhere now. Chatbots, AI translators like Google Translate, and even AI generated images with DALL-E all rely on this technology, which is insane, and it's just gonna get better. So, to wrap things up, GPT isn't just randomly spitting out words. It's using transformers to predict text one word at a time, understand word relationship, and adjust meanings based on context. That's what makes it so powerful. With AI evolving rapidly, who knows what's next? Maybe AI will soon be helping us write books, compose music, even create personalized learning experience. But for now, I hope you have a much clearer understanding of how transformers work. Thank you for listening. My name again is Christopher Gonzalez. Thank you.